Every passing day sees humans delving deeper into the exploration of the universe, whether in attempts to discover new worlds with ideal conditions to potentially harbor us in the future, or through numerous endeavors to find life on other planets, aiming to conclusively establish that we are not alone in the vastness of the cosmos. The increasing modernization of technological instruments, scientific advancements, and the emergence of agencies and research centers are contributing to a growing number of discoveries in this field. Despite the primary objectives of these investigations, they frequently stumble upon intriguing findings, revealing facets of the universe previously unknown to us, planets where it rains glass, others with unusual colors that do not reflect light, or those potentially composed almost entirely of diamonds. It's challenging to imagine such phenomena, yet intriguingly, even though these celestial bodies may not be hospitable for human life, delving into their intricacies offers insight into the vastness of the cosmos and its capacity to create unimaginable phenomena. Let's now delve into the 5 strangest planets known to us, or at least those we have discovered thus far. At number 5, there's CGJ. Was the color emitted by this celestial body, a distinct magenta, or if you prefer, a deep rose hue. Fondly nicknamed the Barbie planet, it's a gas giant, 4 times the mass of Jupiter yet just slightly larger than the king of our solar system, the Sun, with about 1.16 times its radius. Moreover, its orbit spans approximately 9 times the distance from Jupiter to the Sun, challenging our current theories explaining the formation of gas giants. This is especially intriguing given that its star closely resembles our Sun, albeit slightly hotter. However, what truly captures attention is its color. The reasons behind it remain somewhat unclear, though it's most likely a result of the heat emitted during its formation, as it's only about 160 million years old, a mere blink of an eye on the universal timescale. For comparison, Earth is roughly 4.5 billion years old, making it ancient compared to this curious pink-hued planet. At number 4, we have Trace 2b. Speaking of color, let's talk about Trace 2b. Well, it's not exactly about its color, but rather the absence of it due to its inability to reflect light. To give you an idea, Earth reflects about 30% of the sunlight it receives, thanks to its oceans and atmosphere. Trace 2b, on the other hand, reflects only about 1%, making it one of the darkest exoplanets ever discovered. Like the previous case, it's also a gas giant located about 750 light-years away. The exact reason for its extreme darkness is still unknown, but it's likely due to chemicals on its surface such as gaseous sodium, potassium, or titanium oxide absorbing light. Additionally, it's scorching hot, reaching temperatures around 1,796 degrees Fahrenheit, preventing cloud formation in its atmosphere. Consequently, a visit there isn't feasible, at least not for now. Number 3, HD 189733b. Our next exoplanet is also a gas giant, considered quite beautiful yet extremely treacherous and dangerous. We're talking about HD 189733b, located 63 light-years away. It boasts an alluring cobalt blue appearance, reminiscent of Earth's oceans from afar. However, don't be deceived, the blue color comes from tiny silicate particles in its composition that reflect blue light more than red in the visible spectrum reaching us. Now, you might wonder, what's the issue with that? Well, HD 189733b has several peculiarities that would make it highly hazardous for brave visitors daring to cross its path. To start, its orbit is synchronous, meaning one side always faces its star while the other remains in perpetual darkness. This creates extreme temperature and pressure differences, resulting in storms with winds surpassing 7,000 km per hour, a stark contrast to Earth's fastest winds of 300 km per hour. Additionally, its atmosphere is much larger than expected for a planet of its size, leading to excessive radiation absorption. Coupled with its orbit's characteristics, this causes temperatures exceeding 1,800 degrees Fahrenheit. But hold on, there's more. Remember those silicate particles responsible for its blue hue? Well, due to the high temperatures, they fuse, sublimate, condense in the atmosphere, and precipitate, essentially raining down as glass shards. Imagine a place where one side is always day, the other always night, with temperatures above 1,000 degrees Fahrenheit, winds of 7,000 km per hour, and glass raining from the sky. I don't know about you, but that's not on my list of interstellar travel destinations. At number 2, we have PSR 17191-438b. This one comes with quite a hefty name, but it's not just that. Wait until you get to know its characteristics better. PSR 17191-438b is likely one of the most iconic celestial bodies you'll ever come across. Firstly, it's situated a staggering 4,000 light-years away from Earth, making it the farthest astronomical object on our list today. That distance is far beyond our reach, reserved for the realms of science fiction adventures. But that's not all. This exoplanet orbits a neutron star, a small yet incredibly massive celestial body. To put it into perspective, its mass is similar to that of our Sun, yet its diameter doesn't exceed 20 kilometers, about the size of a small city here on Earth. Such density means that just a teaspoon of its material would weigh approximately 1 billion tons. Moreover, it's a pulsar, emitting radiation beams periodically due to its intense but irregular magnetic fields, resulting in unimaginable speeds of rotation, approximately 10,000 rotations per minute. Now, shifting focus to PSR 17191-438b itself, things get truly fascinating. Despite having a mass similar to Jupiter, the largest planet in our solar system, it's only 40% of its size. How did it become so heavy yet so small? Researchers believe it's a remnant of a star whose outer layers were stripped away by the neutron star's gravitational pull, resulting in carbon residues that, under high pressure from gravity and rapid rotation, were transformed into diamonds. Yes, diamonds. Moreover, due to all these peculiarities, PSR 17191-438b is larger than its host star, which is an extremely uncommon occurrence. It orbits very close to its star at an incredibly rapid pace. Records indicate that its orbital period, the time it takes to complete one orbit around its host star, is only 2 hours. This means that a year there lasts just 120 Earth minutes. Imagine celebrating your birthday and New Year's Eve 12 times a day. That's what it would be like to spend time on this diamond-filled exoplanet. And now, at number 1, we have 55 Cancri e. Speaking of diamonds, it's time to delve into what might be the most valuable planet in the universe. Discovered in 2004, 55 Cancri e quickly captured public interest. Initial speculations depicted it as a super-Earth, twice the size and nearly 9 times the mass of our planet. The prevailing theory suggested that it was primarily composed of carbon and iron, heavy elements that hinted at immense value. Predictions at the time suggested that due to high temperatures and gravity, much of the carbon on the planet's surface should have converted into graphite, while about 33% of its inner layers could have transformed into diamonds. Calculations estimated its worth to be around 384 quadrillion times the Earth's GDP, an astonishing figure. However, recent research, including data from the high-tech James Webb Space Telescope, suggests that these estimations might have been flawed. Instead of being home to valuable diamonds, 55 Cancri e may actually be a host to numerous volcanoes, challenging earlier assumptions. So, did you enjoy exploring these distant worlds? I'll leave you here, and we'll meet again in the next video.